Metallic solids. Metallic solids which are contain metals. These are orderly collection of positive ions surrounded by and held together by a sea of free electrons. Here we can see positive electrons were surrounded by free electrons, that is negative ions. These electrons are mobile, that is moving, and are evenly spread out throughout the crystal. And the crystal, in the crystal having a surface, that is crystal lattice, throughout the crystal lattice, these free electrons were surrounded, spread. So each metal atom contributes one or more electrons towards the sea of mobile electrons. These free and mobile electrons are responsible for high electrical and thermal conductivity of metals. If it is supplied, if a metallic solid supplied by heat or electricity, what will happen is these free electrons having the ability to move. So if it is getting further electricity or thermal energy, it will freely move. So due to this movement, with this movement, it will pass electricity and heat. So it is so there is a flow of network of positive ions also. This is similar in the case of electricity and heat. And another characteristic of metallic solids is their luster and color in certain cases. Some cases they will exhibit colored compounds. This is also due to the presence of free electrons in them. And metals are highly malleable and ductile. Then covalent or network solids. So we have seen molecular, ionic and metallic. Next type is covalent or network solid. We know what is covalent bond, sharing of electrons, such compounds. A wide variety of crystalline solids of nonmetals result from the formation of covalent bonds between adjacent atoms throughout the crystal. They are also called Jane molecules. For example, diamond, graphite, silica. If you have seen here, you can see that their layered like structure. Graphite also having layered like structure. So they are called known as Jane molecule. And covalent bonds are strong and directional in nature. So due to this, atoms are held very strongly at their position, and they are very hard and brittle. They have extremely high melting point and may even decompose before melting. They are insulators and do not conduct electricity. Whereas ionic compounds, they also having high melting point, but they will conduct electricity in the case of molten stage. For example, diamond. Diamond having a crystalline lattice. This surface is known as lattice, and diamond of each carbon atom undergoes sp3 hybridization and linked to 4 other carbons, because we know it is a carbon compound. So carbon having the catenation property, it can bond with the same atom or other atoms to form different type of structures such as chain, branched, spherical, etc. So due to this property, diamond having lattice this type of structure, and the CC bond length is 154 picometer. This next one is graphite. Graphite having layered structure. This type of structure is known as layered structure. These layers are held by weak van der Waals force. Here you can see weak van der Waals force. The distance between two layers is 340 picometer. This distance between layers is 340 picometer. And each layer having planar hexagonal ring of carbons. Planar hexagonal ring. Here you can see planar hexagonal ring. Within the layer, the CC bond is 141.5 picometer. And each carbon atom in a hexagonal ring is sp2 hybridized. That is, this carbon is sp2, this carbon is sp2, this carbon is sp2, and it is bonded with 3 neighboring carbon atoms, and the fourth electron forms a pi bond. This makes graphite slippery, and graphite will conduct electricity. So these are the topic. So we have seen crystalline solid and amorphous solid and different types of crystalline solids. Thank you.